go ahead.
Okay, so this is going to explain the code for part 1 of the heat well, or the energy well heat diffusion part. So first, I put a clear command so that it gets rid of any variables so that the default values I set later will work. And then I created a variable called DEC and set it equal to yes, so that this while loop will run as long as DEC is equal to yes. And then in the while loop, I put another clear so that when it reruns the loop after the last line, it'll clear all values and the defaults will work. So then here it prompts the user for 3 variables called n, x naught, and s. And here it sets the default values for x naught, n, and s. And x naught it sets to 20, n it sets to 1000, and s it sets to 5. And then here it creates an empty matrix called solution, well, sol, S-O-L, and fills it with zeros. And this is that, well, x naught, essentially, divided by pi, because that's how many solutions you would have in this problem. And then you prompt the user for a maximum error or a desired precision, and that is Emax. And then I created a variable called, well, y. It'll be used later as a counter. And then it asks the user to input a particular nth interval to find the solution. And here if I made it so that if they don't enter anything, then m just equals 0. And here it starts the main part of the coding, where x is equal to lin space 0, comma, x1 divided by pi times pi, and comma n1. And that just means that it creates an array of points from 0 to x1 divided by pi times pi, and the number of points is the n1. And then c is equal to just cotangent x, a is equal to the square root of x naught squared divided by x squared minus 1. And then the error, or ER, is just equal to the absolute value of the difference between the two. And then the if statement at the top says that if the user entered precision is greater than the error found, then the solution in the that part, round x divided by pi plus 1, is, well, that denotes like which spot it takes up in the array or matrix, is equal to whatever the x value at that point is. And then afterwards it sets the Emax equal to the error found. And that ensures that if the error, well, the maximum error the user enters allows for multiple points to count as solutions, then it stops at the minimum value. And then this is where we use the y variable created earlier, and that just says that for every time that it doesn't find that to be the Emax is greater than ER to be true, then it just adds 1 to y, and that'll be be shown later. Why we do that? Oh, it's right here. And then if that statement says that if the y is equal to n1, so that would mean that it found no solutions because the if statement earlier was never found to be true. Then it displays a warning message. The entered values for precision and number of sampling points generate no solutions. And here it controls the size of solutions. So if the user enters like 15 for the number of solutions and the actual number is less than that, then it sets the number of solutions equal to the number of actual solutions, or the maximum possible. And here it just says if m is equal to 0, then the program stops. Or actually here it just makes the while loop stop. And here, this displays the mth interval, the solution at the mth interval. So this part says if the matrix is empty at, or has a 0 where the mth, where m is, then it displays this. And if that's not true, then it just displays the solution. And then if neither of these are true, or like they enter in an interval that's greater than the actual, I guess, time intervals, then it displays this message. And then this part of the code plots the function, the cotangent x and the square root of x naught squared divided by x squared minus 1. And then this part just makes the cotangent plot red, and this part just makes it cyan. I don't know how to pronounce it. And then this scales, and this changes the label. And then this asks the user to enter a value for, or answer if they would like to find another solution or not. And this part makes it, the apostrophe s apostrophe makes it so that it doesn't treat whatever you enter here as a variable and try to execute it. And if you put yes here, then this entire part from the while down to here goes through again. And then if you put no, then it goes down to this part. And if you put anything other than yes or no, then it just goes to here and stops the program. And this part is here because the earlier if m is logically equal to 0 break and only stops the while loop, and this actually stops the program. I think that's it. Yeah.
Should we run the code too?
I guess 1,000, and then 50, 6, and 1, and 4. And then this is just the plot of cotangent x versus the square root of x naught squared divided by x squared minus 1. Yes, exit. And then it shows the solution at the fourth interval there. And then, I guess, yes. 2,000. 3, 0.1, and 2. And there's the plot again with 3 intervals this time. And then here's the what happens if the interval asked for has no solution. The program found no solution within the